Today with Two Engineers Garage. Today what we're going to be talking about is how to fix a Centec inverter. Say if you accidentally backflowed AC current into it. Just a quick backstory here if you might be wondering how might somebody do that. So if you're at your garage, we got a small solar setup and we just got two circuit breakers right up here. One labeled solar, one labeled grid, so we can flip the grid power and solar power on and off. So, you can accidentally leave one on or something, and you get some AC flow and current back into this guy. The unit we're working on today is a 2,000 watt, item number 69662. So what you're going to need is you're going to need to source out the new chips online. This here is what it takes. These are actually some good ones that I checked, that I pulled last time, and I got a couple brand new ones there. The other thing you're going to need is a multimeter. You don't inherently need a expensive fancy one like I am using here. Just a simple freebie Harbor Freight multimeter is going to get the job done all the same for you. I just have nicer, so I prefer to use nicer. So the very first thing you're going to want to do is grab yourself a Phillips screwdriver. Go ahead, there's going to be 8 screws in the corners here on the outside, and that's going to allow you to take this whole clamshell open here. And then once you get this open, excuse me, there's some wires that attach these two boards together. So you're going to have to get up in there, I believe still with the Phillips head, take the 4 screws out and drop this board down. So I'm going to go ahead and finagle that out of there, and then we'll move. Alright, so now we got that done. You can grab your multimeter. For mine, I have it set on this will do, I believe it's continuity, resistance, and diode. So I put it on the diode setting. Let's see here, yeah, even your cheap Harbor Freight multimeters, they do have a diode checker, which is that setting there. So there's no difference there. So what we're looking at here is we're looking at obviously these big chips. They're going to be stuck down to that thermal padding right there. And when I had fixed this inverter before, I added a little bit of just regular computer thermal paste on here, which looks like this stuff has been baked pretty decent because it's pretty hard. So that's kind of interesting. But what you're going to do is you're going to put it on your diode check-in function. Okay, and then we're going to check for ground on the center pin, and then let's see if I can do this with one hand. So ground on the center pin, positive on our outside pin, or it would be, so on the back of the chip it's going to be the leftward pin. As we can see, there's virtually a dead short. There's virtually nothing. Whereas if we come here to one of these back chips and do the exact same thing, we get the forward voltage of the diode. So it's about 0.5 is a good one. So I've gone through and checked it on this one. The front two either side are shot. So I got to unsolder them and then resolder in with some good ones. And then we're going to give it a test and hopefully everything works. Alright, so we got the soldering work done. And I went ahead, I have the luxury, I got a benchtop power supply. So I went ahead and set that to roughly 13 volts. And then dialed the current all the way down. Hooked it up to the inverter, and then just kept ramping up the current until it would actually power the unit. And the unit draws like 0.6, which didn't seem to be anything abnormal. Just sat there on, didn't make any weird frying sounds or anything like that. So I'm going to assume that's good. Obviously, of course, you want to check all your solder connections for any cross conduct when you get done soldering them with the multimeter before you go hooking it up to power. Of course, if you don't have a benchtop power supply, no worries. What I'd recommend is getting some thin gauge wire, something like this, or even just take the multimeter, probably leaving it on a fuse setting, but maybe like the 10 amp setting here. Connect this up to ground, and then connect the positive battery to the meter, one side of the meter, and then the multimeter itself up to the inverter, so you can see how much current it's taking. For a big inverter like this, something like 0.5 would be acceptable. Small inverters, even less than that. As long as it doesn't do anything crazy, because obviously, you have a fuse protection here, or even if you just had like a spare fuse holder for like an automotive or something, you put like a 5 amp fuse in there, or something like this, a thin gauge wire. I mean, even worst comes to worst, you burn up your multimeter leads, but that's not a big deal versus, you figure an inverter like that, you're going to have, a whole bank of batteries with a couple strands of 2 gauge, you can do a lot of damage with that. So you just want to be careful, go ahead and, check out your work that way. But in this case, everything looks good. So what I'm going to do is just go ahead, put these little screws and crossbars so this mounts back onto the clamshell, put it all back together, just double check it works. But at this point, it looks like we're good to go and the repair is done. So hopefully this helped you guys out. If you liked it, give it a thumbs up. If you didn't like it, give it a thumbs down. Leave a comment, let us know. Really appreciate it. Have a good day, guys.